Student, now I give lecture on different types of excitation voltage systems in automatic generation control. Under different types of excitation system, first we studied about the introduction to different types of excitation system or the voltage systems. Because the voltage is inversely proportional to excitation, directly proportional to speed. The basic function of the excitation system is to provide a necessary direct control, that is DC, to the field winding of the synchronous generator, that is alternator. The second one is the excitation system must be able to automatically adjust the field current to maintain the required terminal voltage, because the voltage inversely proportional to excitation, that is flux. The DC field current is obtained from a separate source which is called an exciter. The exciter is the heart of the main component of the excitation system, that is voltage control system. The excitation systems have taken many forms over the years of their evaluation. Now, what are the different types of excitation systems used in the automatic generation control? The four types of the excitation systems are used in the interconnected power system for excitation purpose. The first one is DC excitation system, AC excitation systems, brushless AC excitation system, static excitation system. Now we detailedly studied about the each excitation system. Student, now you see the circuit diagram represents the DC excitation system. The DC excitation system consists of voltage comparator, amplifier, exciter, synchronous generator, and then stabilizing transformer, voltage sensor. Okay. Now, the field of the main synchronous generator. This is the field of the main synchronous generator, main field winding, is fed from a DC generator called the exciter. So here the DC generator only is used as an exciter in the DC excitation system, which is called as an exciter. Since the field winding of the synchronous generator is the rotor, the synchronous generator is designed as a field winding as a rotor, armature as a stator. The required field current is supplied to the synchronous generator through slip rings and brushes. In the DC excitation system, we are using slip rings and brushes. So therefore, the maintenance cost is high. The maintenance also that means is important for DC excitation system. The DC generator is driven from the same turbine shaft as the generator itself. That means the DC generator and then the synchronous generator both are coupled on the same shaft mechanically. This type of the DC excitation system has a slow response. Okay, because for example, 10 megavolt ampere synchronous generator, the exciter power rating is 20 to 35 kilowatt only. So therefore, huge, that means DC generator is required for excite the field winding of the synchronous generator. For this reason, the DC excitation systems are gradually disappearing only. That's why I am telling this is the slow response. Okay, students, I hope from the circuit diagram you can clearly understand the working function of the DC excitation system. Then we studied about the AC excitation system. In the AC excitation system consists of alternator. The AC excitation system consists of alternator, synchronous generator, rectifier. What is the difference between AC excitation system and DC excitation system? In the AC excitation system, the DC generator is replaced by alternator. In DC excitation system, the DC generator only is used as a exciter. But in the AC excitation system, the alternator is used as a exciter for the excitation purpose. So therefore, the alternator can supply the required field current to the main field winding of the synchronous generator. This is the main field winding of the synchronous generator. This is the field winding of the alternator, that is the exciter. The amplified error voltage, what that means, that is the V reference voltage minus the terminal voltage of the generator, that is synchronous generator. We are getting the error voltage E. That error voltage is fed to the amplifier, is amplified. That voltage only is called as a amplified error voltage. This amplified error voltage only is fed to the field winding of the exciter. Okay. Then this is rectified. Okay. Because this AC voltage is rectified. Okay. DC. Then that DC voltage only is applied to the field winding of the, that is the main field winding of the synchronous generator. So here two sets of slip rings are used. So the one slip ring is used for feeding the rotating field of the alternator. The other slip ring is used to supply the rotating field of the synchronous generator. So therefore two slip ring, one slip ring for alternator, another slip ring for a synchronous generator. So this is the function of a AC excitation system. You clearly understand from the diagram. Okay. Then the third type of excitation system is brushless AC excitation system. Okay. Now you see the circuit diagram. Okay. So the brushless AC excitation system consists of comparator, amplifier, exciter, rectifier, synchronous generator, and then stability compensator. Okay. And then rectifier and filter. This is the potential transformer. Okay. So in the brushless AC system, the name itself is that here we didn't use the brush. AC system we are using the brushes. The brushless AC system we didn't use the brushes. That means the inverted alternator. Inverted alternator means field is a stator, armature is a rotor. So that's why it's called as a inverter alternator. Generally the alternator is designed, field winding is a rotor and then armature is a stator. But here the inverter alternator means the field is a stator, armature is a rotor. The inverter alternator can be used as a exciter in the brushless AC excitation system. Here we are used the full wave rectifier. The full wave rectifier is used to convert exciter AC voltage to DC voltage. So this is the rectifier. Okay. The armature of the exciter. Okay. This is the armature of the exciter. The full wave rectifier. This is the full wave rectifier. And the field winding of the synchronous generator. All are form the rotating component. Okay. The rotating component are mounted on the common shaft. That means armature of the exciter, full wave rectifier, field winding of the synchronous generator. All the three form the rotating component. The rotating component mounted on the common shaft only. Here what is the function? First the potential transformer sends the actual terminal voltage of the synchronous generator, which is rectified and filtered by the rectifier and filter block. Then the magnitude of the terminal voltage is fed to the comparator and then is compared with the reference voltage. Then the output of the comparator is the error signal. The error signal is amplified by the amplifier. Then the amplified signal is fed to the field winding of the exciter. Then the output of the exciter VF is rectified by DC voltage. That DC voltage is fed to the main field winding of the synchronous generator. So this is the procedure for brushless AC excitation system. The last type of the excitation system is the static excitation system. In the static excitation system, the portion of AC from the each phase of the synchronous generator output is fed to the back to the field winding of the generator. But in the DC excitation, the system of transformers, rectifiers, reactors is used, okay, for static excitation system. The external source of DC is necessary to give initial excitation of the field winding of the synchronous generator. The engine driven generator is used for initial excitation for the static excitation system. It can be obtained from the storage batteries used to start the engine. How to the engine driven generator started by the battery? The engine driven generator is used to give the excitation to the static excitation system. Dear students, in this lecture video, you clearly understand the different types of excitation system. Each excitation consists of what are the component and then the function of each component which are used in the different types of the excitation system. Why the excitation system is required for synchronous generator in the automatic generation control in the interconnected power system. Thank you student for watching this video.